Hello and welcome to Galactic Developments. Galactic Developments is a history of the future told in many events on a common timeline. Year 2668. Ultrametals. Naturally produced ultraactinides are found on the planet Draco. These are very heavy elements grouped around the atomic number 164 on the second island of stability. They have a much higher atomic weight than the superactinides of the first island of stability, and they are much rarer. Ultraactinides have interesting scientific, economic, and military applications. The superactinides of the first island of stability can be obtained in two different ways. They can be mined on a few planets, where they were deposited by a supernova explosion. Or they can be produced artificially in giant particle accelerators, consuming vast amounts of energy and generating entire continents of radioactive waste. Ultraactinides, however, cannot be artificially produced in relevant quantities. Like superactinides, they are naturally generated in supernova explosions. But even the longest-lived ultraactinides have half-lives of only a few weeks. So those generated by a supernova are lost after a short time. For all practical purposes, ultraactinides do not exist in nature, at least not for long, and certainly not long enough to be mined thousands or millions of years later. That is what people thought until the Draco system was discovered. The Draco system is the big exception. There, ultra-heavy elements are constantly recreated. Draco b is a neutron star that orbits very closely around a large highly luminous star. Draco b is so close that it constantly pulls matter from its companion. The matter then forms an accretion disk around the neutron star. And a small part of the accreted matter shoots out from inside the accretion disk as a jet, at almost the speed of light, creating a so-called microquasar. There are several such microquasars in the Milky Way. And this microquasar has a planet, Draco. Draco is much heavier than Jupiter, but hardly bigger. With 12 times the mass of Jupiter, it is almost a brown dwarf. Draco moves in a wide elliptical orbit around the exotic binary star system. Its orbital time is only a few months, and with each orbit Draco crosses one of the jets. The planet is then bathed in a stream of gigatons of relativistic matter. The relativistic particles hammer on the planet. The jet is a gigantic particle accelerator consisting of charged particles, ions of all kinds from protons to relativistic iron nuclei. The jet removes Draco's surface like a giant sandblasting machine. The ions collide with the atomic nuclei on the surface. As a result, many nuclei are smashed. After that, the ions of the jet are a little bit slower, slowed down by previous reactions. Sometimes they now have the right speed to merge with the atomic nuclei there. They are still fast. Fast enough to overcome the electrostatic repulsion of atomic nuclei. And if the energy fits exactly, an ion fuses with a nucleus, creating a heavier one. If the energies do not match, then they continue their race, slowing down step by step, having given off Bremsstrahlung. A titanic flood of gamma Bremsstrahlung rages on the planet, heating the deeper layers to unimaginable temperatures. Fragments of burst nuclei at relativistic speeds contribute even more to the heating. Lakes of quark-gluon plasma form beneath the surface. Exotic particles appear and decay in split seconds. Ultimately, the relativistic ions of the jet transfer all of their energy to the surface of the planet. This is like a recurring supernova. For millions of years, Draco has been bombarded by the particles of the jet. They have merged with the atoms of the planet, creating huge amounts of ultra-heavy elements. Most of them are not stable. They decay immediately. What remains are the few stable isotopes, especially transuranic elements. To a lesser extent, there are also elements of the first island of stability, the superactinides. Some of them have long half-lives. So long that a balance emerged between the constant new production and their decay. There are now more superactinides on Draco than can ever be mined. But Draco's real treasure are ultraactinides from the second island of stability. These elements do not exist anywhere else, and they cannot be manufactured artificially. In the Draco system, nature has created a unique scenario where these elements are naturally produced all the time and can be mined before they decay. However, mining on Draco is not easy. It is already difficult to stay on Draco under normal circumstances. Whereas the planet is farther from its sun than the Earth, the star on the other hand is a blue giant with 100,000 times the luminosity of our sun. So everything has to be shielded by mirrors from the star's radiation. At the same time, the surface of Draco is an inferno of radioactivity. Nothing can survive there. Not even machines. So the mining is done by blasting out parts of the crust from a distance, with antimatter detonations. Since the most valuable elements are below the surface, the miners have to remove a lot of material first. Chains of antimatter pellets tuned to the nanosecond generate directional explosions, digging holes many kilometers deep. That takes several weeks. Then the actual mining of valuable subsurface layers begins. The technique is quite similar, but now the blasted-off fragments are caught and processed. Later, when the planet in its orbit again comes close to the jet, mining has to cease. All technical systems are withdrawn. While the planet passes through the jet and the inferno erupts, the heavy mining gear is safely in an orbit behind the star. After the planet has gone through the jet, its surface features are completely erased. There are no traces left of the previous mining. Then things start again. The mining facilities are restored as quickly as possible. They are positioned in a planetary orbit and start to dismantle the surface. Gigatons of heavy metals are extracted within each cycle. They contain 1,000 tons of superactinides and only a few kilograms of ultraactinides. The superactinides are shipped away to interstellar customers. The rather short-lived ultraactinides are used in place. Large industrial parks are being built in the interplanetary space of the Draco system. In addition to the enormous facilities of mining companies, there are processing industries, industrial applications, scientific institutions, technical service providers, and utility companies. Electromagnetic catapults transport raw materials from the inner system, where the mining happens, to the outer industrial areas. The Draco Ultrakov Vyrobka Group is the major player. The company developed the basic technologies and processes to mine the heavy metal deposits of Draco. Several other companies have licensed the technology since. Much of the infrastructure built by Draco Ultrakov Vyrobka is now used by many other companies. Yet, Draco's orbit changes over time. Its precession slowly rotates the ellipsis around the binary star. In a few hundred years the orbit will have shifted so much that the planet no longer moves through the jet. Then the era of ultraactinides ends. At least for the next 10,000 years. This was Galactic Developments, year 2668. I am a physicist and I have always been interested in history. That's a good combination for the history of the future. I want to stay as close as possible to reality. Above all, this applies to technology, which should be scientifically sound, or at least reasonably explainable. But it also applies to social and economic developments. If you think that I have presented something unrealistically, write me in the comments. Or, if I've raised more questions than I've answered, please also ask me in the comments. If you liked the video, please hit the like button. If you subscribe and click the bell icon, you'll be notified of new episodes. Of course, sharing on social media would be nice. More events from the future can be found at galactic-developments.com. If you have a futuristic topic you'd like me to discuss, drop me a line. If you want to use an idea or add something yourself, feel free to do so. There are already hundreds of events, but I would love to read other stories from this future. Write me if I can help. The future starts now.